All right, so this is the review for summative number 5 in the fall of 2019 for Algebra 2. And the first section that you're going to see on the review is a repeated section from the last test. So what we found was, finishing breakfast, that a lot of kids who relied on their calculator to check their work were much more successful than others. So keep that in mind. We want you checking on your calculator. But the first concept mistake that we want to kind of cover and not see again is the confusion between coefficients and variables. So 9 and 5 and 2 are all coefficients that you're just going to multiply together. So 9 times 5 times 2 is going to give you a 90. But when it comes to combining your x's, so right here and here, remember that now we're looking at exponent rules, and you're going to add your exponents together. So this could be as simple as on a calculator, negative 2/3 plus 2, and then you hit math enter on your calculator. Let's see, I think you get 4/3. Then the same property is being utilized for the y's, but this time when you add negative 5, or again we're going to add these, when you add negative 5 plus 3/5, I think you get y to the negative 22 over 5. And then you have to use an additional property that states anything that has a negative exponent, although it starts in the numerator, it's going to move down to the other side now. So final answer would be 90 x to the 4/3 over y to the now positive 22 fifths power. Apologies if I'm doing any miscalculations. I did not have a calculator when I was keying this, so whoopsies. All right, here, this next one, we've got quite a few properties going on here. First thing I notice is we have some exponents outside of a multiplication problem outside of the parentheses, and we're supposed to multiply these together. So when you distribute like this, you multiply. And the x to the negative 2/3, nothing's happened to that yet. But now this next x becomes x to the second power. And then you can write y to the 0 power, because 0 times 1/2 is still going to be a 0. But remember, anything to the 0 power is just a 1. So this just cancels. I shouldn't have put an x, that's confusing. Cancels. Do this. So now you can finally combine these. That same property we used above, we're going to add the exponents together. And if I use my calculator, because I'm a little fuzzy today, let's see, negative 2/3 plus 2. I think I have the wrong answer here. Oh, boy. Oh, that's because I'm dyslexic. That's not 2/3, that's negative 3/2. All right, so negative 3/2 plus 2 would be, let's see, negative a half. Okay, so positive half, excuse me. So x to the 1/2. Again, apologies at all if we have a whoopsies on my adding. All right, this next question, we have a similar issue with coefficients. So remember, coefficients are just things that you're going to have to type on your calculator or think about in your brain. 14 divided by 28, when you reduce that fraction, it reduces to a 1/2. So your new coefficient to this problem is a 1 over 2, and I don't mind if you leave it like that for now. Now when you look at combining the x's, the rule is we're going to subtract the exponents. I don't know why I can't write today. So negative 2, careful, you're subtracting a negative 2/3 on your calculator. So this becomes x to the, let's see where are we at, negative 4/3 power, I think. And then for the y's, it's the same rule, we're still going to subtract them. So 1/4 minus a negative 3/4 becomes y to the first power. And then we're going to use that negative rule again, where anything with a negative exponent is going to have to move to the other side. So you don't really need the 1 anymore. You can just put y to the first power, or just even y up in the numerator. There still is a 2 in the denominator, and now there's an x to the 4/3 power. So remember, these are the questions where there's a whole bunch of ways you can get to the right answer, and that's wonderful. In fact, I think there's a bonus question on your test where you can solve the same question multiple ways, and if you can go through a couple of different examples of that for me, I'll give you some bonus points for extra credit. All right, remember, anything to the 0 power is a 1. So all of this, because it's being raised to the 0 power, it means that is all equal to 1. So just keep that in mind. Be careful though, because I think we had a question on the last test where there was like x to the negative 3/4 times, and then it had a bunch of stuff. I'm just going to make this up. Like this. Well, in this case, and this is a totally different problem, so ignore me if you're jumping in with us. This part right here, this is equal to 1, right? So this becomes x to the negative 3/4 times 1. And then if you use your negative exponent rule, this becomes 1 over x to the 3/4 power. So this is just an extra example. I'm just trying to warn you, because there's something on your test that kind of looks like that. Alrighty, so this is the new stuff. Rewriting in the other form, radical to rational exponent form. So one thing I need you to remember is the formula itself. So if you have a radical like this, you have an index, and then there's going to be some exponent, and the exponent can be inside or out, it doesn't really matter, and then you have some base. It could be a variable, it could be a number. If I want to go to the other version of that formula, you keep the base number, whatever it is, but the new exponent is going to be divided by the index number. So that's the first thing you have to remember on this question, is how the formula can flip between one to the other. The other thing you have to remember is when you have just a radical like this and there's nothing in the index, you have to remember there is a 2 there. There's no such thing as a first root. Remember just that symbol you guys would call a square root, and that's a really common mistake, is kids think there's a 1 here, but there's no such thing as a first root. So rewriting this to that same formula, you keep x as the base, and then your exponent of 7 is now being divided by 2, which is the square root, where there's a 2 here. Using that formula going the opposite direction though, you have a cube root this time. This denominator is the index, and then your b is your base. And then you can write the 5th power, you can write it outside like this, or you can write it inside, where you do cube root of b to the 5th. But most kids like to put the exponent on the outside. Me too. Alright, this is the good stuff. So these are the radical breakdowns where you want to use that weird little salmon colored chart of squares and cubes and fourths and fifths. And we want to break apart everything here in terms of things that will simplify and things that won't. So first thing I do is I come through here and I say, like, okay, who can I just go ahead and take remember this is a square root, right? So who can I just come through and take the square root of? Well, I can't take the square root of 32, it's not in my list, so I'm going to have to break it down. And same thing with x to the 7th. But y to the 4th is good, so I'm just going to keep it. Unfortunately, z to the 3rd, I'm going to have to break that down. So first thing I do is I look at 32, and I look at my list of perfect squares, which remember is 4, 9, 16, 25, and so on and so on and so on. And which ones of those can be a factor of 32? Well, you want to go as big as possible, so I'm going to go with 16. So 32 is 16 times 2. And then x to the 7th, I'm going to break down as x to the 6th times x to the 1st. So that way I can partially reduce the x to the 6th with a 1 left over. We decided y to the 4th was good, so I'm just going to leave it. And then z to the 3rd, I'm going to break down again like I did with the x's, but this time it's going to be z squared times z to the 1st. So now what I'm going to do is I'm going to go through with a blue marker. I'm going to kind of underline things that are going to reduce. So everything I'm going through with blue here is going to reduce and come out of the radical. And then things that aren't reducible by square rooting are going to be stuck in the radical. So for some kids, what they like to do is go ahead and write down what's stuck in the radical first. So like the 2 and the x and the z, they're stuck in the radical. But all of this stuff that we're reducing, it's going to come out of the radical in its reduced form. So square root of 16 is a 4. And then remember, this is a square root. So square root of x to the 6th would be x to the 3rd. Square root of y to the 4th would be y to the 2nd. And then square root of z to the 2nd would be z to the 1st, which I'm just going to write down z. And that is your final answer. So all of the stuff that breaks down comes out of the radical, and anything that's stuck in the radical stays there. We might see some examples, though, where maybe nothing's left in the radical, and that's okay. Speaking of which, let's look at one of these, the 4th root this time. So if you look in the 4th list, 16 actually is something that you can take the 4th root of. And then same thing here, the a to the 12th is beautiful. B to the 8th, oh, that we can reduce that one too. And so, oh, this is going to be wonderful. There's going to be nothing left in the radical. So every single thing here can reduce. The 4th root of 16, which you can do on your calculator, or you can look at your chart, that's equal to a 2. So make sure you're not telling me 4. A lot of kids think it's square root. It's 4th root. So this is a 2. And then 12 divided by 4 is a to the 3rd, and then 8 divided by 4 is b to the second, and then 4 divided by 4 is c to the first, or just c. So there is nothing left in radical. I'll write that little note. A lot of you guys like to look at my slides. So that's why the slides are looking thorough these days, huh? All right, this is another new topic, and you're going to get to use your factoring flowchart on your test, and it's really just to kind of help you go through the process. So at the top of our flowchart, remember that very first step says to factor out common terms. There's going to be a couple of trick questions on your test that you have to do this, and if you don't do it at the beginning of your problem, it makes your problem that much worse. So for instance, number 8a here, I see we have a common term. Everything here can be divided by a 2. So if you factor the 2 out, you're still going to be left with a trinomial, x squared, and then a minus 8x, and then a minus 20. Now what's left over becomes a pretty simple factoring question. Keep the 2 in front, and this is one of those easier ones because the coefficient is a 1, so what times what gives you x squared? Well, that's really easy, right? That's got to be an x and an x. And then you got to think about your terms right here, multiplying to negative 20. So I know my signs have to be positive and negative, but my factors for 20 would be like 10 and 2, and 5 and 4. So maybe I'll think about my numbers for a moment, and I'll settle on negative 10 and positive 2. And then here's the catch. This is what I like to see on everybody's paper. I want to see you guys checking your arches. This is the key as we get to harder factoring questions. This is a 2x combined with a negative 10x. And if you add those together, you sure do get negative 8x in the middle. So your answer is this right here, the 2 times the quantity x minus 10 times x minus 2. Everything else is just the process of you getting there and the check. This one takes 2 steps. So regardless of whether you take the 2 out at the beginning or the end, it has to be done in 2 steps. So trust your teacher when I tell you it's easier to have it taken out in the first step. All right, now the next question I'm going to write down here because I'm kind of out of room. So 9a, you have the same flowchart, so back to the top again, and we're looking for any common terms. So your common term for an 8 and a 72 would be an 8. They can both be divided by an 8. So we're going to factor the 8 out, and you get x squared minus 9. So I kind of skipped over the factoring flowchart on the previous one. You're supposed to look at the trinomial example. This is a binomial, and we have what's called the difference of 2 squares. And the way the pattern works, essentially, is you take the square root of each term, and then one's a plus and one's a minus for the factors. Sometimes we call these good twin, evil twin patterns, just whatever helps you remember it. So the 8 needs to stay in front, but if you want to think about, okay, I know the pattern is plus and minus, I can put those signs down. Now if I think about taking the square root of each term, the twin factors would be x and x, and then the twin factors here would be positive 3 and negative 3. And if you still don't believe me, you should notice that there's no x's in the middle of this term, so when you check your arches, they should add up to nothing. And they do. We have negative 3x and then a positive 3x. That's why this pattern works so beautifully. Alright, so look out for that to happen on your test. We've had 2 questions in a row where we had a common factor, so keep that in mind. Alright, 10a, this guy does not have a common factor. At first I thought it did, but 26 does not have a common factor of 5. So this is the one where you have to kind of muscle through the reverse foiling process. Remember what FOIL stands for. First, outer, inner, and last. And essentially it is a guess and check, but it's an educated guess, and it comes with experience. So when I start with my first 2 terms multiplying to 5x squared, 5 is a prime number, so it has to be 5x times 1x, because we're not going to utilize any fractions. I'm going to have you jump to the end of the problem now, and I want these last 2 numbers, these guys, they have to multiply to positive 5. So your signs could be plus plus, or your signs could be minus minus, because in order for them to multiply to a positive product, it has to be the same sign. And if I kind of look ahead in the problem, I notice I want my arches to add up to a negative 26, so I'm not going to consider the plus plus. It's going to be minus minus. So while we're at it, I'm going to go ahead and put down 2 negative signs. 5, however, it's prime. So there's only one option for 5, and that's 5 and 1. So the placement of the 5 and the placement of the 1 is crucial. Write that in red. And if I put a 5 here and a 1 here, when I go to check the arches, this is where I see if I did it right. So this outside arch is negative 25, right? You multiply the arches together. And then this arch is negative 1x. And if you were to add those two numbers together, that's the outside-inside part of foiling. You do get negative 26x, which is what we want in the middle. So had you put the 5 and the 1 in the wrong spot, it's an easy fix. You just flip them around, check the arches again, and you have the right answer. So that's factoring. It will get more intense as we go through Algebra 2. This is just like our basic level of factoring. I'm sure we'll see it again on the next test. So if you're panicked and you're like, man, I don't think I'm doing this right, we're going to have to probably hit it again. Doesn't mean leave it blank on the test. I want to give you good feedback, please. This guy, however, this is the last time I'd like to see this standard. This is writing equations. And notice I didn't give you an equation on this problem, so you really have to know how to interpret the equation from the story problem. Jimmy's on vacation and his grandma sent him $350 to spend. He's going to spend $60 per day. Now again, they bolded the word spend. This right here is slope, okay? But because he's spending it, he's losing it, right? So it's losing $60 per day. You can label it if you'd like. So writing an equation that relates his money, which they want you to use y for money, and number of days for x. Let's see. Slope of negative 60 times x. And then if you think about what he started with, remember your y-intercept is your starting point. So he started with $350. So the reason I didn't give you an equation to use for that problem is because you don't need to use point-slope form. When they give you a starting point and a slope, you just have to interpret them and go ahead and start with y equals mx plus b, which is the form you always know. And then remember, for days, days is x, so that means you're going to plug in x equals 4 right there. And let's see, I think I solved this one already. I don't trust my mental math today. He's going to have $110 left. Then this next question, you got to think a little bit. When he has no money left, right? So that would be when y equals 0. If you put a 0 in for y, and you tried to solve the equation, I'm talking the original equation now. So maybe you'd subtract 350, and then you're going to have to divide by negative 60, and your calculator is not going to give you an integer. It's going to give you well, it's rational, but whatever. So it gives you a decimal answer. It's like 5.83 repeating. So think about this. I know logically, if this would round to 6, if this was just like a math problem. But I don't think he can stay on vacation for 6 days. Like, he's going to have no money left. I guess he just won't have money after his 5th day. And that's the way I'm going to notate the answer. So I'm going to say after day 5. That's when he's going to run out of money. He's not going to be able to go spend money on day 6, or at least not his full amount. So if he was trying to pay for a hotel room or something, or dinner, he's not going to be able to have that much money. So use your logic when it comes to rounding on these application problems, I guess. I'm going to move on to question 12a, and that's the last one we're doing here on the review. So we have a tutoring company. It charges by the minute after applying an initial fee. Student A has a 60-minute tutoring session and was charged $88. So right there is an ordered pair. And before I write it down, I got to double check that I'm setting up the ordered pair properly. Student B has a 110-minute tutoring session and was charged $150. So x is measuring minutes, so xy, right? So 60, 88, and then 110, 150, 50. Some expensive tutoring, man. And you get yours for free. Okay, let's go find slope. You do have to know slope formula, but remember, m is slope. So if you get in a jam, just solve for m in this equation, and then you'll figure out how to find slope. So slope is y2 minus y1 over x2 minus x1. So for us, that would be 150.5 minus 88 over 110 minus 60. So right here, I'm going to write that down, and so what does it come out to? $1.25 per minute. And I'm going to label that and everything. $1.25 per minute. Now they want you to use this equation, which will be given to you. You got to pick your favorite ordered pair. So for me, I like this ordered pair the best. And just plug it in. So y minus the y coordinate. The y coordinate from your ordered pair would be this guy, 88. equals the slope you just found, which was $1.25. That's a 5. Gosh, I have a hard time writing today. And then x minus the x coordinate, again, was from your ordered pair, so minus 60. And it doesn't say to do anything with your equation, so if I was you, I would just leave it like this. There's other answers, I would take. If you use the other ordered pair, you might have y minus 150.5 equals 125 times x minus 110. Or if you went ahead and solved it for y equals, I think you get 125x plus 13. So they're all great answers, and I'll have all of them ready on my answer key. You guys don't have to worry about that part. It's whether you know how to use the formula. That's what I'm really asking you on that question. So hopefully we all get 5s on that section now. There's no bonus question on that section this time. Sorry about that. But I hope you all get some good scores. We got homecoming week coming up, so you all want your parents to not have you grounded anymore, I'm sure. All right, good luck.